friends, welcome back. We're going to talk about taking our parent functions and stretching and compressing those both vertically and horizontally. Grab your notebook. Seriously, you're going to need to write this down. Grab your notebook. Okay, grab your notebook, write this down because you will want this information for the future. All right, so here are our rules. If it's going to be a vertical stretch or compression, it's going to be affecting, you're multiplying the whole function. If you're multiplying just your x, like this b is here, then you are, then it's going to be a horizontal. So multiplying the whole function, it's vertical. Multiplying just your x, it's going to be a horizontal stretch or compress. Now, compression. Okay, so looking at these, the absolute value of a. The negative, and you'll learn this in the next video, the negative just tells you if you're reflecting it across the x or y axis. So I don't care if it's negative. What I want you to do is just look at the number itself, so the absolute value of it. If it's greater than 1, so 2, 3, 4, so on and so forth, it's going to be a vertical stretch. If it's greater than 1 and it's attached to your x, it's the opposite. We're going to be compressing it down, okay? Compressing that down. If it is between 0 and 1, so something like 1/2, 2/3, 1/4, things like that, it is going to be a compression or fat. So this is going to be skinny, this is going to be fat. Remember, vertical stretch is going to look like this. Vertical compression is going to come down. Horizontal compression is going to be this way, so it's kind of a vertical skinny. And a horizontal stretch is going to come out this way. There we go, lean into that, so that you can see those. But those get flopped around. So if it's less than 1, it's a compression, unless it's attached to your x, and then it's going to be a stretch on that horizontal. So what does that look like? Well, first you may want to pause your video and write these down. This is what it looks like when it's attached in our format for absolute value, quadratic, all those parent functions. So you may want to write those down. Okay, so looking at that, let's go ahead and talk about a horizontal and a vertical stretch. So first things first, we are going to talk about this is horizontal, y equals x squared. Now remember, that's our parent graph. And so that I've already graphed right here, or I mean, I've already done my XY chart for it right here. And it looks something like this. Go over 2 up 4, over -2 up 4. So there we go. There's our parent graph right there. Now let's talk about this. This is attached to our x here, which means we're doing it to our x, but we're dividing. So we are going to divide our x by 2. So if I do that, I get -1, -1/2, 0, 1/2, and positive 1, making sure I got that right. So what does that look like? So then we don't graph those guys. So we go over -1 up 4, over -1 up 1, 2, 3, 4, over -1/2 and up 1, over 0, 0, and then over 1/2 up 1, and then over 1 up 4. So that ends up looking like this guy right here. So as we talked about, this is horizontal, right? And this is greater than 1. So you can see that it is compressed horizontally. It's coming this way, right? So the 1/2, let's talk about that now. Again, we want to divide our x by that. Now, if we divide by a fraction, we really can't. We multiply by the reciprocal. And what I mean by that is 6 divided by 1/2. We don't do that. We do 6 times the reciprocal of 1/2 is 2. So dividing by 1/2 is the same as multiplying by 2. So instead of dividing, we're going to say multiply by 2. And so if I do that, I get -4, -2, 0, 2, and 4. So if I go over -4 up 4, over -4, 1, 2, 3, 4, up 4, 1, 2, 3, 4, just like that. Over +4 and up 4, that's this one down here. Again, we're ignoring these. -2, +1, so over 1, 2, 1, over +2, up 1, and then 0, 0. So when I go ahead and graph these guys, you can see that this is a horizontal stretch. I'm stretching it out like cheese this way, right? Horizontal stretch because it is less than 1. So that's what it looks like when it is horizontal. Let's talk about what it looks like when it's vertical. So in this case, we're going to use our absolute value parent function. And I've gone ahead and plugged in our XY chart here for these. So if we go ahead and graph that first one, it's going to be, I did a terrible job of drawing a straight line there. I'm just noticing. Geez. Been doing this 20 years, still can't draw a straight line. Okay, so here we go. That is our absolute value function. Now let's talk about this. In this case, we are multiplying the whole function. It's not attached to the x, it's on the outside. So we do it to our y, and we do whatever, we multiply. So times this by 2, we get 4, 2, 0, 2, and 4. And then this goes away. So we go over -2 up 4. 1, 2, 3, and 4 right there. Over -1 up 2. Over +1 up 1, or up 2, I mean, and then over +2 up 4. So you see that we've got a nice, so this is a vertical stretch because we're stretching up. The larger that number is when we're doing a vertical stretch, it's going to stretch up. It's going to become much skinnier. Now, if it's less than 1, so anywhere between 0 and 1, so a fraction less than 1, then we've got, we do the same thing. We're going to be multiplying it to our y, so times 1/2, but you'll see it's much fatter. Actually, let's use a red for that. So times this by 1/2, we get 1, 1/2, 0, 1/2, 1. So we go over -2 up 1, over -1 up 1/2, over 1 up 1/2, over 2 up 1. So you can see that this one is being compressed down, right? It's flattening out vertically. So you can see those are the differences then between vertical and horizontal stretching and compressing. Again, we'll tie this all together in a later video, but I just want you to see that relationship there. If you have any questions, let your teacher know, or otherwise we'll see you next time.